Boris Starosta started making stereo photographs in 1997, soon thereafter pursuing a childhood interest in architectural images. After 2000, his interest turned to buildings under construction. During construction, buildings reveal a greater complexity in spaces and volumes, and suggest a semi-transparency which is especially compelling in 3D images. Around 2005, Boris discovered photographer Michael Wesley's images of the rebuilding of New York City's Museum of Modern Art. Wesley made structures normally considered fixed and solid appear translucent by using exposure times as long as 2 years. None of Wesley's images were stereoscopic. Thus, Boris was inspired to use a multiple exposure technique to recreate this effect in 3D on buildings under construction in his hometown of Charlottesville, Virginia. A new parking garage was the subject of this prototype image. Intermediate images were easily acquired over the course of just 5 days. Floors were laid 1 per day, and the proof of concept was quickly finished. But the final image looked strange because, unlike others to follow, the garage was not built from the inside out. It was built from the bottom up, and so the transparency effects are odd in places. Just a few blocks down the street, a high-rise condo was the first structural steel building Boris photographed using this new technique. This building had the potential of truly looking translucent in the final image because steel buildings are often built from the inside out. That means the entire steel load-bearing structure is already erected before the floors are poured. For every site to be photographed, 2 or 3 suitable shooting locations were selected. One challenge was composing for a building not yet in existence. A bigger challenge was finding a spot where the camera position and pointing could be repeatedly reproduced with millimeter accuracy for the many months of intermediate image acquisition. Starting in April of 2007, numerous exposures were made of a new architecture school edition at the University of Virginia. Every time more exposures were gathered, accurately repositioning and pointing the cameras was critical for pixel-accurate alignment during post-processing. Any deviation in pointing would cause perspective distortions, changing the 3D effect, then making stereo alignments very difficult or even impossible later on. Only by shooting digitally and being able to immediately review images was Boris able to shoot with the accuracy needed. Pixel-accurate alignments are necessary in essentially 3 axes, X and Y on the picture plane, and the Z-axis being a function of X-axis disparities between the left eye and right eye image pairs. While shooting at the new UVA nursing school building, Boris found that one cannot rely on the steel structure as a visual reference for subsequent image alignment. The steel structure shifted with changing loads as construction advanced, sometimes on the order of several inches at various points. Sometimes the builder would unexpectedly modify the building. The steel structure up here appears to have been removed a month later. It looks like the correction of an error discovered as the work progressed. These issues interfered with both camera pointing and post-processing. It would confound Photoshop's automatic image alignment tool and force very time-consuming manual image alignments. While a fully translucent building closely mimics Wesley's long-duration exposure technique, one advantage to the multiple exposure method is that there is complete freedom in how to blend the images to create some very different effects. Whenever possible, a series would start with exposures of foundation work, followed by additional exposures as the months went by. Occasionally, selected shooting locations were wiped out by environmental changes. Builders would block the view with a trailer truck or something like that. Or, the chosen photography location would cease to exist. At one point, a building Boris was shooting from simply vanished, having been torn down at the commencement of another construction project. All these unpredictable factors made continuation of a series increasingly nerve-wracking as the building neared completion. For example, Boris had selected a third viewpoint for photographing the nursing school building that he thought foolproof. Up on a third-floor balcony of the neighboring UVA French house, he was sufficiently far above the alley that surely nothing would ever block the view, and the alley was also too small for the bigger cranes, so it seemed a safe location, and there was a great view into the foundation structures. Yet, after only the second exposure, just 6 weeks into the shooting, the impossible happened. The French house was getting a renovation, and a scaffolding was put up all around the building. If the series of images was to be completed, then the camera position could not be shifted. One could either quit this viewpoint or keep going. He kept the viewpoint, expecting the scaffolding to be gone before long. But the scaffolding remained in place some 3 months before renovations even began, and then another 3 months before they were finished. Only the last exposure, taken almost a year later, was no longer blocked. On any of these buildings, losing the ability to shoot the final image would nullify many hours of work accumulated over the preceding months. That final image was essential to achieve the look of a translucent building. But what if the final scene lost all commonality with the initial views? How could one enable accurate image alignments throughout all the intermediate images? In this view of RUFFIN Hall, the Fine Arts Department building at UVA, despite the odds, Boris got lucky. In the final view, the only common elements that remained were a frat house in the upper left and one 6-foot section of curb at the lower right. Why that small bit of curb was preserved is a mystery, but it was essential for the successful completion of this image. For imaging the unique roof of RUFFIN Hall, one of the shooting locations was atop another nearby building. Here you can see how the tripod would always be set up exactly the same way, using marks made at the location, verifying the camera position with careful measurements to reference points in the nearby space. Prints of exposures made on preceding visits, with reference points marked in the image, would help with repositioning and repointing the cameras. Even so, there was still the difficulty of having reference points from earlier exposures hidden or blocked in the newer exposures by the ongoing construction. One of the last buildings photographed was the open space building. Here, a fairly wide stereo base of nearly 3 feet between the cameras was used. This is one of 2 viewpoints obtained from the roof of a building across the street. The wider baseline preserved a nice 3D effect, even though the distance from the building was greater than typical. Boris continues to seek an audience for these unique images, and would love to find an institution that would support additional explorations of this technique. He looks forward to utilizing more modern, higher resolution digital cameras and a significant improvement in method. Larger, more detailed images would result. The images could be useful for education, or public relations and outreach, or as documentary images for architects, builders, historians, municipalities, and/or schools.